Since the appearance of 3D printing in the 1980s, the technology has come a long way to become highly appreciated by professionals. First created for rapid prototyping, 3D printers proved useful in quite a number of fields, from heavy machinery to the beauty industry, not only for making prototypes, but also for consumer goods, batch production, and much more. This is Top 3D Shop, and in this video, you will get to know everything about the professional segment of 3D printers, as well as the best models of FDM-based devices, with more types to come in one of our next videos. When one plans on purchasing a 3D printer, the first question to answer is what the device is going to be used for. Based on your particular needs, you can complete a list of requirements, and that will serve you in making a decision. Further on, we are going to discuss some key points to help you with the list. The first thing to consider is the printer type. The most common printing processes to date seem to be material extrusion, vat photopolymerization, and powder bed fusion, hence the technologies we are going to consider in this two-part review. Fused deposition modeling, FDM, stereolithography, mostly LCD-based devices, though other interesting technologies are present, and selective laser sintering, SLS. For SLM 3D printers, which are designed to print in metal powders, check our dedicated overview. The choice of the printer type depends to a great extent on your particular requirements, as all the technologies have their strong and weak points. FDM-based machines are probably the most affordable of the three, and they prove extremely useful for rapid prototyping or producing end-use parts with relatively simple designs, where high precision and smooth surface finish are not put first. It's also a great option for hobbyists due to a wide selection of low-cost models in the market to choose from. Based on vat photopolymerization process, resin 3D printing, on the other hand, allows for highly detailed prints with a perfectly smooth surface finish, but they always require certain post-processing. Such equipment is a good choice when precision is a key point, in areas such as dentistry and jewelry, for instance. SLS technology has been traditionally employed for industrial applications. Such machines are generally significantly larger and more expensive than FDM or resin-based. They turn out to be extremely efficient in creating strong functional models with very complex geometries. Now let's dwell upon some of the key parameters affecting the choice of a professional 3D printer, such as resolution, materials supported, and print quality. Resolution is the first thing to come to mind when speaking of the printed object quality. The XY resolution is determined by the smallest possible movement of the printer's head, while the Z-axis resolution is commonly referred to as layer height or layer thickness, and many manufacturers use this parameter speaking of the printer's resolution in general. The thinner the layer your machine is able to print, the more detailed and precise model you'll get. Resin 3D printers are capable of providing the highest resolution of the three technologies under discussion, while FDM machines evidently lose this battle. The choice of consumables naturally depends on the technology the printer is based on. FDM printers use thermoplastics in the form of filaments. Resin machines employ various types of photosensitive liquid resins. Engineering-grade thermoplastics in the form of powder are used in SLS printing. Speaking of professional 3D printing, we can't but mention a whole lot of special-purpose materials used by industrial-grade machines, when specific properties of the final parts are highly needed. Those can be composites like carbon fiber or glass-filled materials, different high-performance and engineering-grade plastics, special dental resins. A print bed, that is, a plate on which a 3D model is printed, also plays quite an important role in the overall quality of your prints, as it defines how the first layer is printed. If your print bed shows poor adhesion, for example, the entire model can be completely ruined. Apart from quality components, professional printers usually offer various features that add to consistent failure-proof printing, like auto bed leveling system, or magnetic, flexible, or removable build plate. While working with high-temp materials, a heated bed plate is necessary. So, in what areas of applications are professional 3D printers actually game changers? Obviously, some require purely professional-grade equipment, while less demanding areas benefit from higher quality it provides. Originally created as a powerful means for rapid prototyping, 3D printing has proved itself indispensable in this field. The use of additive manufacturing allows for significant cost reduction and time saving while creating prototypes, compared to traditional tooling. It lets engineers develop new designs of almost any complexity with further testing and modifying at no additional cost. All possible design failures can be spotted and fixed in early stages of product development before it comes to mass production. 3D printing is not only good for prototyping. End-use parts manufacturing can benefit from its advantages to a great extent. Professional and semi-professional machines are now utilized for producing high-quality end-use parts either as a bridge to traditional manufacturing or, in case of complex designs and not-so-large production volumes, as a full-cycle method. Additive manufacturing provides wide opportunities for custom-built products as well as for low-run production when injection molding, for example, is of no efficiency. Another application of 3D printing is producing spare parts for discontinued models, thus prolonging the life cycle of a product. Medical and dental industries today are among those adopting additive manufacturing technologies most rapidly. One of the benefits of professional 3D printers, namely their ability to create high-quality custom-made products, makes it a perfect tool for producing patient-specific devices, such as prosthetics or implants. In dentistry, 3D printed crowns, bridges, aligners, and surgical guides help reduce the cost and waiting time, yet allowing for the creation of perfectly fit devices for every patient. 3D printing can also be employed in surgical planning to produce organ models that doctors use for surgery preparation. The use of professional 3D printing in jewelry has given a boost to the industry development and set up new standards in jewelry design. The possibility to print objects of extremely complex geometries and ultimate customization options open unlimited opportunities for the designers and provide the customers with absolutely new, fascinating jewelry pieces. And now we'll get on to the list of the best professional 3D printers in today's market, and in this video, we will talk about FDM machines. The best professional resin and SLS 3D printers are going to be discussed in Part 2. Let's start with so-called semi-professional devices, for those who would like to get a serious machine while keeping under budget. The Cheedy Tech X-Max is an FDM 3D printer with a spacious build volume of 300 by 250 by 300 millimeters and a fully enclosed build chamber. The X-Max can print layers with the resolution of 50 microns, providing detailed high-quality parts. It comes with two interchangeable extruders with nozzle diameter of 0.4 millimeters. One is for printing PLA, ABS, and TPU, and the other is for high-performance materials such as PC, nylon, or carbon fiber. The heated, flexible, removable print bed allows printing on either side. Among smart features are an air purification system, print pause, and power outage resume functions. The next printer on our list is the high-temp version of the Creality CR5 Pro, which features a large, fully enclosed build chamber of 300 by 225 by 380 millimeters. Equipped with a heated print bed and an extruder that can reach 300 degrees Celsius, it allows printing in ABS and other high-temp filaments with a diameter of 1.75 millimeters. The machine boasts a carbon glass-coated print bed heated up to 110 degrees Celsius, which ensures good adhesion and easy removal of the prints, as well as an auto bed leveling system. The filament runout sensor, print resume function, and cloud printing support provide continuous operation, reducing the risk of failures. The CreateBot F160 Peak is a high-temperature modification of the CreateBot F160 model, the difference being in the maximum nozzle temperature of 420 degrees Celsius, compared to 260 degrees Celsius for the F160, and the build chamber that can heat up to 70 degrees Celsius. Alongside the build plate with the maximum temperature of 150 degrees Celsius and fully enclosed build chamber, this allows printing with high-performance materials like PEEK, ULTEM, and carbon fiber reinforced filaments. The minimum layer height of 40 microns ensures high-resolution prints, the maximum print speed of up to 300 millimeters per second, and a set of useful features place the printer on the side of professional equipment. The Cheedy Tech iFast is an industrial-grade 3D printer compatible with a wide range of materials, including PLA, nylon, TPU, PETG, ABS, PC, wood, and carbon fiber-filled filaments. The dual-extrusion system allows printing PVA water-soluble support structures or multicolor parts. With the maximum nozzle temperature of 300 degrees Celsius, the device features a fully enclosed build chamber heated up to 60 degrees Celsius and a magnetic removable heated build plate. The thermal insulation system helps prevent any temperature fluctuations inside the build chamber, ensuring precise warping-free printing. With the fairly large build volume of 330 by 250 by 320 millimeters, you can print sizable parts or multiple single models in one go. The FlashForge Creator 3 features the independent dual extrusion system that allows you to print two models simultaneously, either in mirror or in duplication mode. It also makes it possible to print soluble supports or multicolor objects. Like in the previous device, the high-temperature extruder provides compatibility with a large number of filaments, including engineering-grade materials such as nylon or carbon fiber reinforced plastics. With the minimum layer height of 50 microns, the Creator 3 provides precise, durable, dimensionally accurate parts. The build volume of the printer is 300 by 250 by 200 millimeters. Now let's move on to the next level equipment, professional-grade 3D printers from the higher price category. Featuring a large build volume of 400 by 300 by 300 millimeters, the CreateBot F430 is a high-performance device employing a dual extruder, with the left 260 degrees Celsius hot end for printing with PLA, ABS, PC, nylon, carbon fiber, and flexible filaments, and the right 420 degrees hot end made of martensite steel for printing with materials such as PEEK, Ultem, etc. The print bed, heated up to 120 degrees Celsius, is made of ceramic glass, and together with the 70 degrees Celsius build chamber, it prevents warping. Functions like the print resume and filament detection stand for consistent 24/7 printing. The Fusion 3 F410 is an industrial-grade 3D printer that boasts its rigid metal enclosure and F-Series motion control system, which help minimize vibrations, thus ensuring fast, accurate prints. The interchangeable print head is equipped with a hardened wear-resistant steel nozzle, suitable for printing with abrasive filaments like carbon fiber. The multi-zone heated print bed features the bed level compensation technology, which levels the build plate before every print. With a noise level of only 36 decibels, it is a perfect choice for office workspaces and educational institutes. The Intamsys FunMat HT model is available in 2 modifications: the enhanced version featuring automatic bed leveling, a ceramic glass magnetic removable build plate, and a software-improved bed motion system. Designed to work with high-temperature consumables, the device easily handles plastics like PEEK. This ability is provided by the advanced thermal system, including 450 degrees Celsius extruder with an all-metal hot end, a 160 degrees Celsius heated print bed, and a heated build chamber with the stable temperature of 90 degrees Celsius. The FunMat HT Enhanced supports a wide range of materials, including those produced by third-party manufacturers. The minimum layer height of 50 microns ensures highly detailed, precise prints. Characterized by a rather affordable price for such a professional machine, the Raise 3D E2 sports an array of benefits, including the independent dual extrusion system called IDEX. With the high-temp nozzle and heated print bed, it is possible to work with a wide range of materials, including carbon fiber, glass-filled nylon, and others. The E2 comes with 2 0.4mm nozzles, which can be replaced with optional nozzles of 0.2 to 1 mm in diameter. The minimum layer height of just 20 microns provides exceptional surface quality and allows for the use of the E2 in applications requiring high accuracy, such as dentistry. A set of smart features, including multi-zone bed leveling system, a built-in camera, and a filament runout sensor, ensures consistency and predictability of the printing process. The Raise 3D Pro 3 is another dual extruder FDM printer with a build volume of 300 by 300 by 300 millimeters. Intended for professional use, it is equipped with quite a number of helpful features to ensure consistent high-speed printing of accurate parts, as well as top-quality, reliable structure. The Pro 3 is compatible with a wide range of both proprietary and third-party materials. The flexible steel build plate with an auto-leveling function provides proper first-layer adhesion and easy removal of the final part. The built-in camera, power loss recovery function, filament runout sensor, and door open detection contribute to safe, failure-free continuous printing. And the last category of professional 3D printers for today will be large format units for those who need to print big. With a build volume of 600 by 600 by 600 millimeters, the CreateBot D600 Pro offers high performance in a variety of industrial applications, as well as incomparable value for money. The printer is equipped with a dual extruder mechanism with the maximum right hot end temperature of 420 degrees. Unlike the original model, D600 Pro boasts a hot air chamber that can maintain a stable temperature of up to 70 degrees Celsius, which allows for quality printing with materials subject to high shrinkage, like ABS or nylon. The printer is also equipped with a filament drying room and a heated ceramic glass build plate with an auto-leveling system using a BL Touch sensor. Designed by the Swedish-based FebTop Tech company, the Optimus P1 is characterized by a modular design and comes as a kit, though the assembling process will hardly take longer than an hour and a half. Probably the most noticeable feature of the Optimus P1 is its ability to work as a laser engraving machine, the switch between the printing and laser engraving modes being simple and quick. The Optimus P1 has a build volume of 600 by 600 by 1100 millimeters, a heated print bed with the maximum temperature of 100 degrees Celsius, and an auto-leveling function, and the layer height of 500 to 80 microns depending on the nozzle size. With the CreateBot F1000's huge build volume of 1000 by 1000 by 1000 millimeters, large-scale printing possibilities are limited only by your imagination. The new auto-rising dual extrusion system with the maximum temperature of 420 degrees Celsius is equipped with interchangeable nozzles. You can use brass, stainless, or martensite steel, or ruby nozzles depending on your project. The available nozzle diameters range from 0.4 to 1.5 millimeters. Printing with high shrinkage materials is no longer a problem with the fully enclosed heated build chamber. The rigid construction and the accurate linear guide rail minimize vibrations and ensure accurate filament feeding, thus excluding possible warping and stringing issues. The brand new generation of Modix 3D printers include an extensive lineup of considerably upgraded machines for industrial applications. The smallest model has a build volume of 600 by 600 by 660 millimeters, while other options sport truly enormous chambers. For example, 1800 by 600 by 600 millimeters in the Big 180X model, and a cube with an edge of 1010 millimeters in Modix Big Meter. All the printers come as kits with detailed assembly guides and videos. Compatible with an impressive range of materials, the fresh iterations are equipped with a plethora of new design tweaks, making for a significantly improved experience and results. For more details, check out our overview of the 4th generation of Modix 3D printers. This is Top 3D Shop with a short guide on professional 3D printers and the overview of the most prominent FDM machines in this class. Subscribe to our channel, leave your comments below, and hit the like button if you enjoyed the video. See you soon.